In this system, these are parallel fifths, and these are parallel thirds. Now listen to this, and tell me if it sounds like there's a pattern. You don't have to define how the pattern works, just can you hear the pattern? That was from Ludwig Göransson's score to Oppenheimer, and quite elegantly for a movie about a brilliant theoretical physicist with a conceptual theme about nuclear chain reactions. We get a gorgeous score with its own brilliant musical chain reaction.
I needed to write some music that also had the math and science in it. It's kind of like an exercise, a mathematical exercise.
The reason this string line sounds patterned is because it is. Looking at the notation though, what is the pattern? You might take these 6 notes as a unit, and I think you should, and notice that the first note of each unit goes up by step. The other notes don't all follow suit. Notice that consecutive notes form intervals that are inconsistent. For example, the first idea doesn't have any fourths, but the next one does. Charles Cornell did a video reacting to this music, and when he looked at the notation, he said,
"It gets so confusing." And that's because it's not just following a pattern.
I think he heard a pattern, but then couldn't describe what it was, and then decided that means there is no pattern. That's not a great way to do music analysis, though, because your analysis should align with your experience of the music, or at least with an experience you want to have of the music. What he ended up doing was instructive, though. He showed how this music's pattern is not a standard one taught in most music theory classes, but there is a pattern.
It's almost like an exercise. It's a very simple pattern.
There is a pattern, but I wouldn't call it simple. In order to understand what's going on, I'm going to review what are called diatonic sequences. Then I'll explain how the pattern in Oppenheimer is different and so hard to describe if you don't know what to look for. I'll create my own notation system so that you can literally see not only the pattern, but also some spectacular symmetry built into it. By the end of this video, you should not only understand the pattern, but also have the tools to compose your own original ideas inspired by it. These patterns are instances of what theorists call a musical sequence. Especially in the context of Oppenheimer, I like to think of a sequence as a chain reaction from a catalyst. We start with a musical idea called a model, and then repetitions of that idea move sequentially up or down. Usually the model moves up or down by step according to an underlying scale. In Can You Hear the Music, let's take the first 6 notes that go up as a model, and then the 6 notes that start going down as another model for our sequence. Before looking at what Ludwig Göransson did with this, I want to apply a more standard formula first. So let's measure these in terms of a pitch collection with 1 sharp, and we can move these models up by step or down by step. Let's start by taking the first model and moving it up by step within the context of that G major pitch collection. This is a very Baroque sounding technique, and I'll add some light accompaniment that moves along with the sequence. And now here's our other model, but moving down within that pitch collection. There's also no requirement that the contour pointing up has to go up, or that the contour pointing down has to go down. So I could do the reverse and have the first motive go down, or the second motive go up. Ludwig Göransson is creating a musical sequence with this motive, but there's one key adjustment. I think that probably counts as a pun, by the way. His underlying scale for this sequence is not the full diatonic pitch collection with 1 sharp. His pitch collection only has 6 notes. You could call this set G major without A, or the way the composer himself referred to it as,
I had a B minor and a C major. You have 6 notes.
The general term for pitch spaces with 6 notes per octave is hexatonic. Pitch collections with 7 notes per octave are much more common, and the word for them, which no one really uses, is heptatonic. One possible heptatonic system is called diatonic space, which includes the modes of a major scale. If you have 8 notes per octave, you'd be in an octatonic pitch space. There are also 5-note pitch spaces called pentatonic, and this might be even too niche for this channel, but 4-note pitch spaces would be called tetratonic. Okay, but back to Oppenheimer. Right now we're oriented within a particular type of hexatonic pitch collection. A step in this space is motion between adjacent members of the collection. A step up from F sharp goes to G, and a step up from G now goes to B. To move from the model to its copies, you can move everything up or down by step, but you have to do it within this hexatonic pitch collection. Western notation can make these relationships pretty hard to see because it works really well for 7-note scales, but in a hexatonic space, you'll have different vertical amounts of space between steps on a regular staff notation. This sequence might be easier to visualize if I make up a notation system for it in which there are 6 steps per octave. I could set lines to correspond to each note of the pitch collection. Notice that if I have parallel hexatonic thirds or hexatonic fifths, the vertical space in staff notation will be inconsistent, but they'll appear parallel within my hexatonic grid. Now with my hexatonic grid notation, you should be able to literally see the pattern Ludwig Göransson composed into his score for Oppenheimer.
And you just go up the scale, the 6-note scale, and then you go down again.
It is a bit more complicated than that, because the composer made some little adjustments to the pattern so that the upward and downward sequences feel connected by step. This notation should also make it easier to see something really cool which is happening here. In this pitch space, the upward motive goes +1, +1, +2, +1, -2. And the downward model is an exact inversion of the original idea within this hexatonic pitch space. It goes -1, -1, -2, -1, +2. If you were only measuring intervals in a diatonic pitch space, though, there would be no inversion, at least not an exact one. It is a brilliant theoretical design for a brilliant theoretical physicist, but there's a little more that Ludwig Göransson does to craft this into something special. When I made those little Baroque sequences, you may have noticed that I added some accompaniment, and the accompaniment followed the pattern of going up or down by step. However, in Oppenheimer, the sequence is only in the melody. There are harmonies that are moving much more slowly, which recontextualize those melodic notes. Importantly, they also make use of a full 7-note pitch collection, including the extra note A. Here's some quick guidelines for how you might want to compose your own music inspired by this technique. But first, let's check how well you understood this. I made the beginning of a hexatonic sequence here. Can you continue the pattern?